Okay, let's take it one after the other. This is the question one. Composition of function. We have the first thing we have there is a function f of x, which is here. Function is here. Function f of s. Sorry, this is f of s divided by f of x equals 2x minus 1. And we have g of x divided as what? X squared plus 1. Now they now say we should find the composition of the two functions. Yeah, this is the question. Find f compose g of x. And f compose g of x, when you have f compose, what I wrote here, what I typed here, f compose g of s is the same as f housing, and that's the bracket, f housing g of x, which I have here, f housing g of x. All together here. Of course, what do we need to do? Just put g of x inside this place first. Put g of x here. You put g of x inside this place, this whole place first. That was what we did here. What is our g of x? G of x is x squared plus 1. Are you get what I'm saying? So since g of x is x squared plus 1, obviously that was what we did here. We substituted g of x for g of x here. Do you understand? So this is our old g of x. We put it there. X squared plus 1. Now we now need to remember that there's a definition they gave us for f of x. I believe we don't forget. Now, since they said f of s is this, f of s is actually this place. Very good. Yeah, that's our f of s. If f of x equals 2x minus 1, then somebody will say, what will be f of 2? It means that will be 2 into bracket 2 minus 1, which is actually what? 2 times 2, that is 4 minus 1, 3. If that was your guess, then you are correct. Are we together here? That is what actually our f of 2 is. Now, if f of 3 is going to be what? Put anywhere you see x in this relation, the relation, anywhere you see x in that relation, all you need to do is just to put 2 there. So that's going to be 2 into bracket 2. Sorry, 2 into bracket 3 minus 1 for f of 3. That's going to be what? 2 times 3, 6 minus 1, 5. F of 7, that's going to be 2 times 7, 14 minus 1, 13. Now, what is f of x squared plus 1? And when you see x here, do you understand? You put x squared minus 1 there, and that was what we did here. We put x squared minus 1. It is still 2 into bracket, but instead of s, it's going to be x squared plus 1. Close the bracket, then you have a minus 1. And obviously, what would that give birth to? Open the bracket. 2 times s squared, we have 2s squared here. Then 2 times 1, we have 2. Then we have a minus 1 outside. So 2 minus 1, we get a what? 2s squared plus 1. And that is the solution to that number 1 question. I believe that is clear. Thank you. Now, since we've been able to get, are we together? We've been able to get what our f compose g of x, the general composition of the two functions, that is f compose g of x. But then they said we should do it at a point x equals 3. And what does that mean? And we see x in this beautiful function we have here. Yes. And then we see x there, and what we have there, that's 2s squared plus 1. Anyway, you find x there, put 3. So we substituted 3 for x. Let me use a better one. We substituted 3 for x here. God bless you. What do we put there? Instead of 2x squared, we put 2 3 squared. That is, instead of s, we put 3. So that will be put 2 times 3 squared plus 1. And 3 squared is what? 3 times 3, 9. 2 times 9, 8. 2 times 9 is 18. 18 plus 1. This one should have been plus 1. And that's how we got the 19 we put here. So our answer there is that, so we say, so f compose g at g of 3 is actually 19, just as before. Are you together here? So that is, they don't mind the language I put this method, find the general solution for this. Now, the first method, that's what we are trying to say. That is, it will give you the general solution for f compose g of x. That was the first thing I did. So that it will be easy. What if in another question they say, okay, find if it is the same function. And the summary of it is that for composition of function, just house it. They said, let's assume they said g compose f of s. Then you put f of s inside that bracket first. You now go and record the definition of g of x. And when you now see x, then put what your f of s is. Put it inside that x, then expand or simplify. That's how we run composition of function. And if they limit it to a point, just set that point. What do I mean by limiting it to a point? Like this one here, they limited the function to what? X equals 3. So anywhere you just put see your s, put 3. Let's assume they limited it to x equals 4. Anywhere you see s, you put 4, and without to get your beautiful answer right there. So that's the solution for question number 1. Now the next one is for we to play with it. They said given that alpha and beta are the roots of an equation. Root of an equation. They said alpha and beta, this one definitely, for we to have only alpha and beta as a root of the equation, definitely it must have been what? A quadratic equation. How do I know? A quadratic equation, we have 2 roots. And with what they gave us here, we are having 2 roots. That's why I said it will definitely be what? A quadratic equation. Now they've given us the root already. They said alpha and beta are the root, and they've given us the sum of the roots and the product of the root. And I believe you don't forget that when you have the sum and product of the root, then to get a quadratic equation back, we have something like this, the general format, given the sum and the product of the root. Even if you don't have the sum and the product of the root, if you only have the root alone, you can take the sum yourself. That's the first answer, add to the second answer, the root, altogether here. And what's the meaning of the root of an equation? The root of an equation are the values to put into that equation for you to get for the equation to be balanced, like for this statement to be obeyed. If they said it is equal to 0, then the root of an equation are the values you put into that equation to get a 0. Are you get what I'm saying now? So that is very simple. And by a curve, if you have a curve, let's say I draw a quadratic curve now. Yes. So the root of an equation is actually this point. Let me use another ink. This is where our root of the equation lies, this crossing point and this crossing point here. Sorry. This point. Those are the roots of the equation. The point where, on this point here, on this plane, on this, don't mind me, on this other plane, on this straight line, we say what? That is the point where our y equals to 0 on this x straight line. So if y equals to 0 at that point, then where the curve crosses that point is the root of the equation. But now they've given us the 2 roots. And what did they want us to do? Given the 2 roots, they just said, okay, you don't have to do much. What you want to do there is just something as easy as it looks. Are we getting what I'm saying? Now, what they want us to do with the root they gave us, is that they want us to now compute the equation. How will you do it? I said this is the format. X squared minus sum of roots with x plus product of roots. They've already given us the sum of root to be what? 3. Product of root to be 2. So anywhere you find the sum of roots here, put 3. And for the product of root, put 2. And that was what we did here. We have x squared minus into the sum of root is 3. Then close it with x plus 2. Of course, what would that be? 3 times x, 3x plus 2. So the quadratic equation with sum of root 3 and product of root 2 is actually what? X squared minus 3s plus 2 equals 0. So that is the solution to question number 2. Now on to question number 3. They said if log y raised to power half base 2 equals log 5 log 125 base 5. Then we need to get the value of y. What do we need to do? The left hand side is where we have the busy looking guy. And don't forget, for we to simplify the left hand side, that was what we wrote here. Simplifying the left hand side, we don't forget the rule of logarithm, which is what? When your number, like what I have here, what we have here, that's what I'm talking about, what we have here, this point. Very good. Now, when your number is, we call this one a raised to power c is the number. Don't forget that by the rule of logarithm, when your number is having an exponent, if your number is in an exponential form, then the exponent can multiply both the logarithm, the number, and the base. And that was what we did here. That log a raised to power c base b is the same as what? C, the exponent multiplying the logarithm, the number, the base. And the number here is a, the base is b. So that will be c times log a base b. And that was what we did here. So our exponent here is what? Exponent here is 1/2 or half. So the half is going to multiply logarithm y base 2. Now simplifying the right hand side here. Simplifying that, what do we have? We know 125 is the same as 5 raised to power 3. 5 raised to power 3. So that will be log 5 raised to power 3 base 5. And from the rule we wrote here, the same thing suffices for what we did here. I get what I'm saying? So that's going to be 3 log 5, 3 log 5 base 5. And when you have log a base a equals 1, that is when you have both. Now this is supposed to be 3 log, don't mind me, let me use another ink, log 5 then base 5. But these two guys, when the number and the base is the same thing, you get 1. So 3 times 1 is 3. That's where we got our 3 from. So the answer for that right hand side is 3. I get what I'm saying? That is our half log y base 2. You know, we've simplified the LHS to be half log y base 2, and that will be equals to 3, what we got for simplifying the RHS. So the next thing is for we to do what? Simple. We got actually half, don't forget, we got half log y base 2 equals 3. The next thing, multiply both sides by 2. Then that will get the half at the LHS of. And 2 times equals 3. 2 times 3 is 6. And that's what we got here. And the next thing you want to do, of course, convert from indices to logarithm. That will be, of course, you hope you don't forget how to convert. That will be the base raised to power the result here equals number. The base to convert from logarithm to indices. Let me write something beautiful to that regard. Let me write something beautiful to that regard. We say if you have log, let's say log y base s. Log y base s, if it is equal to b, then definitely your y will actually be x raised to power b, and that's it. Do you get what I'm saying? That is, so the y here is going to be what? 2 raised to power 6, and 2 raised to power 6 is 64. So the answer to this question is actually y equals 64. Now the next thing we want to do is just to come back to, the next question, question 4, is polynomial. They give us a polynomial f of x equals 2x raised to power 3. The polynomial here, 2x raised to power 3 plus x squared minus 3x plus p. And they said that x minus 2, when it divides this our given polynomial, we got a remainder of what? A remainder of 20. Hey, don't forget remainder's theorem. That if f of s is divided by x minus a, then f of a is a remainder. If f of s is divided by x minus a, then f of a is a remainder. Very simple. That is, when you substitute a for x, anything you get will be the remainder. Instead of you doing the long division with this remainder theorem, makes it easy for you to get the remainder without going through that long division process. Are we together here? Provided your polynomial is divided by a linear expression. And here I have a linear expression which is polynomial of degree 1. You know, polynomial of degree 1 is linear, polynomial of degree 2 is quadratic, polynomial of degree 3 is what? Cubic, and like that. So once you have a linear equation, just set that linear equal to 0. Anything you get for x is going to be anything your x is equal to. Like in this situation now, I will say x minus 2 equals 0. So my x is going to be what? 2. So my a here is 2. All you need to do is to substitute 2 for x here. I get what I'm saying? Substitute 2 for x here, for x here, for x here. So that will be anywhere you see x, and this is a beautiful looking guy, put 2 there. So that will be 2 into bracket 2 raised to power 3 plus 2 into 2 raised to power 2 minus 3 times 2, then plus p. Are we together here? So that is it. So with that, what do we get? Now, 2 raised to power 3 is 8. So your f of 2 is going to be what? 2 times 8. 2 raised to power 2 is 4. 3 times 2 is 6 plus p. That will be what? 2 times 3, 16 plus 4. That is 20 minus 6. That is what? 20 minus 6. That is 14 plus p. But they've said it is equal to 20. So all we need to do is actually to set our 14 plus p equals 20. And with that, our p is going to be what? 20 minus 14. When you bring this one here, you bring this one to this side. So the positive here is going to be negative here. So 20 minus 14 is 6. So the answer to the question is 6. The answer to the question is 6. Thank you. The next one is this question. They said they give us a pH equals minus logarithm the what do you call it, hydrozonium ion, like that. That is minus log H H3O plus, the hydrozonium ion. Now something here for you to get, don't forget, if we don't put any base at all, here, you know there's no base here at all to this logarithm here, there's no base, then it is in base 10, note that, it is in base 10. Then rearranging this, that is converting it to indices. Praise the Lord. The first thing we can do is here, we can get the minus here off the way. By the what? Dividing both sides by minus. When you divide both sides by minus, the minus is going to be off the way. Then you have the minus at this side here, at this side of pH. That's it. So the next thing, convert the logarithm like what we did in the previous video. Convert this logarithm to indices. Then h, the number here, will be equal to what? The base raised to power the result. And that's how we get h, the hydrozonium ion, equals 10 raised to power minus pH. And what is our pH? They gave us the pH to be 7.1. That will be what? Then the hydrozonium ion is going to be what? 10 raised to power minus 7.1. 10 raised to power minus 7.1. And simplifying that, we get 7.94 times 10 raised to power minus 8 mole per liters. Are we together? And that is the answer to that question. It's as easy as it looks. Very simple. First thing you need to remember here, this one here that did not put any base, if it is not base 10, if it is any other base, every other base, they must put it there. So base 10 is not compulsory you put it. If you put it there, it is good. If you put it there, it doesn't really change anything. Base 10 is not what you must put there. So when you see that there is no base in your logarithm, then it is in base 10. Are we together here? So what we need to do, the first thing, get the minus here of the way, follow the procedure, of course. Then you get your answer so